Saxon Advanced Mathematics Lesson 102. We're going to talk about binomial expansion. This is a part 2. You may remember that we talked about binomial expansion way back in lesson 77. And so we're going to take what we learned then and we're going to build on it ever so slightly. You'll remember that what binomial expansion means is that we take a binomial, such as that, and we expand it, quote unquote, by raising it to a power. Now this one you may have memorized. Over the years, we've done that enough times. And we can easily figure out a plus bi to the first power. That would just be a plus b, right? But what about a plus bi to the third, or the fourth, or the fifth, or the sixth, or the seventh, or the eighth? We want a way to be able to calculate those binomial expansions without having to multiply our brains off every time, right? So what we learned in lesson 77 is that there are two tools that we can use to do this. The first thing that we have to figure out in these expansions is what are the coefficients that go in front of each term? And then the other thing we have to figure out is how do the exponents behave? So what we learned in lesson 77 is that we have two tools for making that happen. The first one, let me just cover up the second for now. The first one we learned, oh, this doesn't really show it. It's called Pascal's triangle. Pascal's triangle looks like this. When we raise a plus b to the 0 power, we just get 1. When we raise a plus b to the first power, the coefficients are 1 and 1. When we raise it to the second power, it goes 1, 2, 1. And we learned that there's a very strong pattern for making this triangle. Let's practice it right now. I'm going to rewrite these over to the side. A plus b to the 0 power, a plus b to the first power. We're going to use this triangle again in these problems. These should have quantity markers. A plus b to the 4th power, and then let's go up to the 5th power. Once you get this much done, it's easy enough to add extra rows if you need to go higher in your exponents. Anything raised to the 0 power is 1. So we start with a 1 in the middle. When we raise a plus b to the first power, it's just a plus b. So the coefficients are an invisible 1 and 1, right? Now the triangle is started and we don't really even have to think anymore. Although we can double check our answer here because we know that it's 1, 2, 1. What's happening is that we are adding together the two coefficients that are above each place to create the new place. We always start with a 1 on the outside, then we add together. 1 plus 2 is 3, 2 plus 1 is 3, and then we put a 1 on the outside edge. All right, so creating this triangle becomes just kind of a mechanical process. We don't really have to think too much about it. A plus b to the 4th power, we start with a 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then 1 on the outside. Get it? We just create this pattern, and this is going to tell us what the coefficients are when we actually want to write out the expansion. And let's do one more. 1, 5, 10, 10, 5, 1. All right, so that is Pascal's triangle. And let me find out, what can we find out about Pascal? They don't tell us anything about who Pascal was in that lesson. But this is super useful because we can use that to create the coefficients, again, when we are trying to do an expansion without doing all the multiplying. Now, the other question is what to do about the exponents. Oh, let me point out one more thing. The number of terms that we have, okay, this is the exponent, but over here, I'm going to write the number of terms. When we raise to the 0 power, we have 1 term. I'm going to have to squish a little bit here at first. When we raise to the 1st power, we have 2 terms. 2nd power, 3 terms. 3rd power, 4 terms. 4th power, 5 terms. 5th power, 6 terms. So the number of terms is always 1 more than the exponent, right? That's important. That's going to help us as we do this. So the number of terms is 1 more than the exponent. Okay? That's helpful to know. All right, now we're going to look at the pattern of the exponents. This is all review, by the way, of 77. We haven't gotten into anything new yet. So this is the pattern of the exponents. And what we're going to do is instead of calling it A plus B, we're going to start using the notation of F plus S, first plus second is all that means, all right? And what we find is that for any number of terms, and again, we'll go up through, we want to, let me just pull this out so I can flip it more easily. We're going to make, we have 5, we're raising it to the 5th power, so we want 6 terms. So we'll be raising this we're going to use this as the example. And so we know there are going to be 6 terms. So I'm going to write F and S, and then I'm going to write 1, 2, 3, 4, 5, 6. These are the terms. And this will be the exponent on the 1st term, the exponent on the 2nd term. And the way that works, we're raising to the 5th power, so we go 5, 4, 3, 2, 1, 0. So the exponent on the terms for the first part of the binomial are going to start high and then drop down. And then for the second part of the binomial, they're going to start low, start at 0, and build up. Okay? If we're doing a different number of terms, we have to rewrite this chart, right? Pascal's triangle can work for any of, it's useful for any different scenario here. We could always add if we needed to the 6th power. But this one we have to recreate for any different number of terms. Now, what's cool about this is that if we have these 2 charts, we can expand to any binomials we want. And last time, we did that with some fairly easy binomials, some simple ones, and now we're just going to up our game. So let me just remind you, let's work a problem and then I'll tell you the steps. I have the steps, but they don't make sense unless you've seen them in action. So let's start into the example. 102.1, find the 4th term of, here's the binomial, minus 3x plus 2y squared. Okay, so what do we have? We have a big, icky binomial. It's got exponents in it, not to mention other coefficients. Oh my gosh, what a mess. And we're raising it to the 4th power, and we're trying to find the 4th term. Our brain says, oh, is that the last term of the 4th power? No, it's not. because we know that if we're raising it to the fourth power, that means it has 5 terms. So we look at our Pascal's triangle and say, okay, this is the row we'll want to use, right? 1, 4, 6, 4, 1. So I'm going to copy this to the other page. That when we raise to the fourth power, our coefficients are 1, 4, 6, 4, 1. Okay, I copied that out of Pascal. If you were doing this as homework, you wouldn't necessarily even need to copy the whole thing. Now we need to know, so now we know what the coefficients are. We know we want the fourth term, but it's okay, we'll just write them all down. Now we need to know what the pattern of exponents will be. Here are our terms, right? 1, 2, 3, 4, 5. And so we know that the exponents will go, I'm going to draw a little line here so we don't confuse the coefficients with the exponents. The coefficients will go, or the exponents rather, 4, 3, 2, 1, 0, and then 0, 1, 2, 3, 4. We had to recreate this. You have to recreate the pattern of exponents for every different exponent. It's not like Pascal's triangle where we can just take out the row we're interested in. We have to keep recreating that. But these two pieces of information give us everything we need to know. The biggest problem now is how to consolidate all this information because these terms are so creepy. So here's what we're going to do. We're going to define f and s as minus 3x is our first term and 2y squared is our second term. Now we're going to keep this information to the side, and what we're going to do is we're going to start recreating that fourth term that we're looking for by using just f and s, and then at the very end we'll plug back in these values. We don't want to work with this cumbersome mess. That's too much. So what we're going to do is hone in on, we want the fourth term, and we numbered them, so this is 4. So these are the pieces of information that we need to use to create our fourth term. Second, I'm just looking at my notes here. Okay, so we know that our fourth term is going to have a coefficient of 4, and then we're going to take f and raise that to the first power, and we're going to take s and raise that to the third power. Make sense? This is a simplified version that we're creating because we do not want to deal with new coefficients, new exponents on top of these wicked terms. So we're substituting in these much simpler ones. Once we get this, then it's the next step to put these back in. So then it will be 4, f1 is minus 3x, that's to the first power, and then 2y squared, that is to the third power, right? There's where I got that. Coefficient is 4, exponent on f is 1. Well, I've got written it right here too. Exponent on s is 3, so I'm just bringing down those exponents by plugging this in. Okay, now what I'm going to do is simplify the exponents. I'm going to use the power rule to distribute those exponents across all the bases in the parentheses. Don't forget the number in the parentheses. So then this becomes 4 times, let's see, this is just minus 3x, and this becomes 8y to the 6th. All right, so we do our simplifications, and now we're ready for our final calculation. We're going to bring together all the numbers. 4 times 3 is 12. 12 times 8 is 96. It's going to be minus because of that. So we have minus 96, and then we have x, and we have y to the 6th. This is that fourth term, right? If we wanted to expand and write the whole row of what you get when you raise a plus b to the fourth power, we could do that, but we've just done one piece of it, and this is correct. there is a problem where we're gonna have to do the whole row and it'll make your hair stand on end. Okay, so let's go back and look at the steps we followed in creating that term. This will help you. All right, so what we're gonna do is we will first we're going to find the appropriate coefficients and exponents for the term we're trying to find. The coefficients will come from Pascal's triangle. And the exponents come from what I'm calling the pattern of exponents. So those are the two tools we use to find those numbers, all right? And we have two more examples, so you'll get a better idea as we go. That's the first step. Second step, define F and S. Right? We remember what they're equal to, but we set those more complex meanings aside, and we're just going to use F and S. Then we write the expansion using F and S, and then we plug in the actual values and simplify. Okay, so that's what I just did. That's what we're going to do again. There are the steps written out in words if that is helpful to you. All right, let's try the next one. Like I said, there are 3 in all. This one, boy, I'm gonna need more space. Forget about that. Example 102.2. This is the one where John wants us to do the whole expansion. So not just one term, but the whole row. And it's gonna be long. 2a squared minus x to the 3rd, and we want to raise that to the 4th power. So we're going to have a total of 5 terms. We know that, right? Because there's always one more term than there are exponents. Okay, so we first need to find the coefficients and the exponents. All right, so we want to know what are the coefficients on a plus b to the 4th. We know there will be 5 terms. And then we're going to want to know the exponents on the 1st and 2nd. For this, we need our Pascal's triangle. I'm not going to recreate it every single time. I don't expect you to recreate it every single time. It's kind of like the unit circle. Make sure you know how to create it, and then you can use the same one over. Okay, we're looking for the 4th power. So that's right here, 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. So those are the coefficients we will put on each of our terms. We know that the first binomial, the first part of the binomial will have the exponents going down in order. Whoops, 4, 3, 2, 1, 0. We're raising it to the 4th power, so we know the biggest exponent will be a 4. And then this one starts at 0 and goes up. Beautiful. So now we can write out, let's just write this. F equals 2a squared and S equals minus x cubed. That'll be tricky. We'll have to watch that minus sign carefully. All right. Now we're ready to write out the expansion using f and s. So the first term will be 1 as the coefficient, f to the 4th, s to the 0. Plus, the second term is 4, f to the 3rd, s to the first, can't talk, plus 6, f to the 2nd, s to the 2nd, right? I'm just going down each row, plus 4, f to the 1st, s to the 3rd, and then the last one will be 1, f to the 0, s to the 4th. Okay, so there we have our pattern in simplified form. Now what we're going to do, well, before I do anything else, I'm just going to drop these two pieces where we're raising to the 0 power, because we don't even need that, right? And we don't even have to look at these. So now for every f, I'm going to drop in 2a squared, and for every s, I'm going to drop in minus x cubed. Whew, it's going to get crazy. I'm also going to drop off this 1, because we don't need that. So the first term is 2a squared. Oh, well, that's kind of nice. We don't even have to come back and simplify it later. 4 f to the 3rd power, and then s, we don't have to raise that to an exponent, that's fine. Okay, plus 6. As much as I can keep these over, above and below each other, it's helpful because then my eyes are not wandering all over the page. Just like this, if we can keep these in nice, neat columns, it just helps us get the problem done more efficiently and effectively. Okay, 6f 2a squared, also squared, times s minus x cubed, also squared. I'm starting to run out of space, but let me try. 4 times f to the 1st power, so that will just stay the same. 2a squared times minus x to the 3rd raised to the 3rd. And then this one I'll just squish it, plus 1 s to the 4th, so it's just minus x cubed to the 4th. That's really hard to read, I understand. As we go through and simplify it, you'll get one more chance to take a look at those numbers. Okay. Ready? Here we go. This one is fine. 2a squared. This one, I have to bring those down. So it's going to be 4 times, let's see, the 2 cubed will be 8. The a squared will be a to the 6th. And then it will be minus x cubed, also being multiplied. So that means this will become, I'm going to go one more row down. This is 32, but it's minus 32. A to the 6th, x to the 3rd. See how I did that? I brought the numbers and the minus sign together, and then I just listed the 2 letters. Okay, so this is kind of like my working row. This is my final answer. Okay, plus 6 times, let's take this 2 and distribute it, and then that 2 will also be distributed. Okay, so this becomes 2 squared is 4 times a squared raised to the power of 2, so we multiply those, that's a to the 4th. The squaring, if you think of this as a minus 1 in front of the x cubed, I know it's really hard to see, but if you think of it as we're squaring the minus sign, you can think of that as squaring minus 1. That goes positive. So this just becomes x to the 6th. And so what we get here is a positive 24 a to the 4th, x to the 6th. Boy, they clean up so nice, don't they? All right, let's do this one. 4 stays the same. 2a squared stays the same. We have to distribute that third power, this is going to stay minus, right? 3 minus 1s is still a minus 1. And then x to the third raised to the third is 9. And so that becomes, let's see, 4 and 2 are our numbers, plus we have a minus sign, so that's minus 8a squared x to the 9th. And then our last one, we're raising it to the 4th power. So our minus is going to go plus, and that's going to become plus x to the 12th. This is our answer. Let me double check it. Oh, I made a mistake. Did I? That first term, two a squared, oh yeah, the 2a squared has to be raised to the 4th power. I didn't do that. Look, see, I have the 4 right there, but it should have been this, and then this should have been 4 times 2 is 16, and then this would be the 8, so this should be 16a to the 8th. I'm sorry, I neglected to raise that to the 4th power. Even though I wrote it there, I skipped it there. And I probably confused you and made you wonder, what? I don't think I understand. Okay, so this is the proper first term. Then we were back on track. Minus 32a to the 6th, x to the 3rd, plus 24, a to the 4th, x to the 6th. I'm writing this because I don't trust my eyes to just listen and know it's right. Minus 8, a squared, x to the 9th, plus x to the 12th. Okay? This is the right answer. That is what you get if you multiply this thing by itself 4 times. This is a long, tedious process, but I think I'd rather do this than actually multiply that out 4 times, although that would work. My mistake was that I forgot to raise this first term to the power. I just completely neglected to bring that exponent down. I think I was so excited about crossing out this one and this one that I'd made it too easy. But it's okay to make mistakes, right? The important thing is to find them and learn from them. And that's what I did. Yay. Okay, we still have one more. I know, these are really long, aren't they? Let's be honest. Everything that we do from here on to the rest of the year is probably going to be long. And from on in your math career, because you're just too smart. Okay, so we want to find the third term of the expansion minus 3x plus 2y squared raised to the 5th power. Okay, the 5th power tells us there are going to be 6 terms, so I'm going to write 1, 2, 3, 4, 5, 6. First, I want to go to Pascal's triangle, and I want to find the coefficients. I kind of used up number 1 space, but that's okay. Here's my Pascal's triangle. And I go to my thing and I realize I do have it to the 5th power. I was going to say, let's say we were raising it to the 6th power, it's okay, just take the chart you have and just add 1 more row. Or let's say we needed the 7th power, we'd have to add the 6th, but then you could calculate the 7ths, right? So we can use this and add on to it as needed. So my terms are 1, 5, 10, 10, 5, 1. Notice the nice patterns that they make. It's super cool. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. Beautiful. Now the exponents. The first term and the second term. The first term is going to start at 5, go down. And the second term is going to start at 0 and go up to 5. We have been tasked with finding the third term. So these are the values we need, right? We don't have to do the full expansion this time. All right, let's define f as minus 3x and s as 2y squared. All right, so we'll plug those in at the end. I'm following my list of steps. Where is it? Come here, a little list of steps. So we found the coefficients and the exponents, right? We used our resources. We defined f and s. Now we're going to write the expansion using f and s instead of the actual values. So our term will be 10 times f to the third and s to the second. Boy, after doing that great big long one, this seems like child's play, right? It's so much easier. Okay, so now we are ready. Get my steps back. We wrote the expansion using the f and s. Now we're going to plug in the actual values and simplify. All right? So now we're going to write 10 times minus 3x to the third times 2y squared squared. Now we're going to take care of these exponents. Multiply them by each base. We get 10 times, let's see, this minus sign, I can think of as minus 1 to the third power. That's going to stay minus. 3 to the third is 27. And then x to the third, because it's just a plain x there. All right? 2 to the second power is 4. And then we have y to the fourth. Beautiful. Now I'm ready to multiply all these numbers together. I know my coefficient is going to have a minus sign at the front because of that minus sign, so I'm going to put that there. 27 times 4, and then we'll multiply it by 10. I don't know this one off the top of my head. 8, 2, okay, 108. So this will be 1,080 because we're going to multiply it by 10 as well, right? 27, 4, and 10. So 1,080 is the coefficient of our term, our third term we're creating. And then x to the third, y to the fourth. We've already straightened them out. Let's double check and make sure I didn't make any mistakes. Minus 1,080, x to the third, y to the fourth. Yay, this is right. After doing the full expansion, these problems where we're asked just to find a particular term seem super easy, don't they? Okay, you have everything you need to be dangerous with lesson 102. I hope you enjoy it. And I will see you next time for a little dip into the logarithm pool. So be ready for that. Okay, thank you. Goodbye.